Hey everyone, welcome to the talk. Okay, cool. Getting some feedback in the channel. I only have one screen, so I'm gonna start sharing it up. Let's see how this looks. Cool. So, welcome to the talk on the secrets of the Gradle Build Scan plugin. My name is Nelson Osacky. And let's get started. So when I started making this talk, it was actually called the Gradle Build Scan plugin, but it's now called the Gradle Enterprise Gradle plugin, which I don't know. I don't think it's that great of a name. Gradle Enterprise Gradle plugin user manual. But in this talk, I'll just refer to it as the Build Scan plugin. A little bit about me before we get started, because we've got to make things personal in this Corona times, because you're all just little I don't know, chat bubbles on my screen, and I'm just a little thing in your video. So I was previously working at Square in San Francisco on Square Register and Build Tools. I'm currently working at Soundcloud in Berlin, and je parle un peu de français. J'étudie à l'Université de technologie de Compiègne. It has a really beautiful building that I'll stick right there. Don't worry, that was the only slide I'll do in French. I'm the maintainer of a couple Gradle plugins. Fladle makes it very easy to run your Android tests on Firebase Test Lab. Delect is a plugin that automatically swaps Dagger for Dagger Reflect, and a new plugin I developed called the Gradle Doctor that we'll talk about a little bit today. Okay, so before we get started, what is a build scan, or a Gradle Enterprise, Gradle, whatever you call it? A build scan is a little thing that tells you information about your build, and it at the end of your build, you get a little link and you click it and you see all this information, right? And this is just an example from SoundCloud. And the thing is, there's a lot of information, but what do you do with this information? And that's what this talk is about. How do you take the information in your build scan and turn it into actionable information? Because really, data is just data, and but what you need is to make it actionable. So some pieces of information from this build scan that you can gather. When you compare build scans, you can see that these two build scans have different Java runtime environments. We'll talk about why that is a problem later. In a build scan, if you took a look at one of the pages, you might see that a build is spending like 90% of the time in garbage collecting, which can be a huge problem for slow builds. And in this case, this build is spending a lot of time annotation processing, which we can skip with Dagger Reflect. So yeah, you get a build scan after every build, but you're not going to check every single build scan after your build. It's just a lot of information to get to. So how do we take that build scan data and turn it into actionable insights? Let's start with the mismatched JDK, right? So what's the problem we're trying to solve? If you have a mismatched JDK, which can happen if your Android Studio, for example, is using the built-in JetBrains JDK, which it does by default, and on the terminal, you run the Oracle Java JDK or OpenJDK or whatever JDK you have as your Java home, the problem will cause this mismatched Gradle daemon. And what happens then? Well, you basically get two Gradle instances. And let's say your heap size for Gradle is 6 gigabytes, and you accidentally spawn an extra daemon when you run from the command line. And you also have Android Studio running. And what about Chrome? We all have 16 gigabyte MacBooks. We're already using 16 gigabytes. What about your other apps? So you're gonna run out of memory, right? So the goal is to share the Gradle daemon between Android Studio and the command line by reusing the daemon. Here, I just made some cool animations for these slides. So yeah, we want to reuse the Gradle daemon. How do we do that? We tell Android Studio to use Java Home. And then it can use the same Java instance that the terminal is using because the terminal is also using Java Home. Okay, so these are the instructions to tell Android Studio to use Java Home. And the thing is, we put these in the onboarding, and we've sent out emails telling developers to do this, but no one follows instructions. And at the end of the day, you know, there's now a warning in Android Studio about this. It's a really great message there. But yeah, nobody reads warnings. Like, no one digs into these things. So how do you get people to reuse their Gradle daemons? You can also like walk around teammates' desks. You know, I made this slide earlier, and you can't really walk around a teammates' desks anymore. So how do you solve an issue like this programmatically? We can basically disallow multiple daemons by failing the build. So how do we do that? Okay. So the first attempt I had at trying to solve this problem is, I'm smashing the keys. Sorry, I was just looking at the feedback. I have a mechanical keyboard, okay? I'm not smashing the keys. But thank you for the feedback. I'm going to glance down at the chat every once in a while because it's kind of funny. Okay, so if you're running if you're running in the terminal and you want to check how many Gradle daemons are running, this is kind of a useful command just to know. PSAUX, this will give you all the processes on your computer. If you grep that for Gradle daemon, then you start to get all the Gradle daemons. And then I just like kind of filtered this information. You can see here on the slide that I have one Gradle daemon that's using Gradle 6.1. Another one is using is also Gradle 6.1, but it's using the Android Studio JDK. Yeah, I don't know if you guys can see. I don't have a mouse cursor. There's another one that's using JDK 12. And then there's another one that's using an older version of Gradle. So I have 4 Gradle daemons running on my computer. And then if you pipe that into wc-l, you'll get a result of 5. There's an extra 1 in this case because this command grep also has the argument Gradle daemon, so it gets counted in as part of that. But yeah, you can just subtract 1 at the end. So how do you do that from Gradle? Well, okay, so there's going to be a lot of Gradle samples in this talk, so just some information about them. Any of these samples can be placed in any build.gradle.kts or build a normal build.gradle without Kotlin. You can also put in your build source. In the Gradle Doctor, it's packaged inside the plugin, and you can find a lot of these samples in the Gradle Doctor plugin that I'll have at the end of the talk, or I'll have a link to it at the end of the talk. Okay, so how do you run this command in Gradle, check if there's more than one daemon, and then display a warning to the user? You take that command and you turn it into a bash command, which is this is just an array of strings. And then you can call this is actually just Java code. This has nothing to do with Gradle, but you can do runtime.get runtime.exec, and that'll call that bash command. And then you have to wait for it to finish. And then you read the bytes back. So in this case, it's going to read back 5. You subtract 1, and you get 4, and that's the number of Gradle daemons running. Easy, right? And if you have more than one daemon, you throw an exception. So that was the first approach I took at solving this mismatched JDK problem. One issue was if you're working on multiple projects, this doesn't allow you to work on multiple projects. So that's kind of annoying. And if you're running tests using the Gradle test runner, test kit, which runs a separate project with its own Gradle instance, it'll also throw an exception. So So that's no fun. So second attempt. Like I said earlier, we just want the Java home between the Android Studio and the command line to match for just our project. We don't care how many Gradle Damons really are running. I mean, we do, but that's not really the problem we're trying to solve. So we want to make sure Android Studio is using Java Home and the terminal is using Java Home. So we can also check that from Gradle. So we can check the system environment variable. Again, this is just Java code, but you can stick this in any build.gradle file. And you can also check what Gradle's Java home by checking the Java virtual machine's current Java home. And so you basically just take those two and check that they're matching. And so from the terminal, this will be matching by default because Gradle will by default use the Java home unless you're doing some magic. But from Android Studio, this will fail because Gradle will by default use the embedded JDK, which is not going to match the Java home environment variable. So what you do is, yeah, a very simple string comparison. You check if first that the Java home is set, and second that it matches the current Java home. You can also, if you have like symlinks in your for your Java home, you should check that they're real paths. Otherwise, they may be referring to the same location, but the string won't be equal. So if you stick this in your build.gradle file, this will ensure that every developer in your project is sharing the Gradle daemon between Android Studio and the command line, because they literally won't be able to build if they don't set them. Now, obviously, and so then after that, once that's fixed, this is what that looks like. You can see that the Gradle daemons are now matching. And sharing is caring. That's what is all important here. When you share Gradle daemons, these days everything's about the sharing economy. So your computer is also about having a nice sharing economy. Okay, so I hope that made sense. So on to the next part, right? For this next part, we're just gonna get into a little basics of Gradle because it gets complicated later in the talk. So we're gonna do. I'm gonna show you how to do like basic build measurements, like how long the build took, right? So you can add this code once again in any build.gradle file. So if you just do gradle.add build listener. You get, obviously, like if you take a measurement at the start of the build, and then you get this callback at the end of the build, and then there's also a simpler version of this callback. You can just do gradle.build finished. So if you grab the time, if you just stick the time measurement at the top of your build script, that'll be when the build starts. And if you measure the time when the build finishes, then you can very simply print out how long the build took. So that's if you just take this snippet of code, stick it in your build script somewhere, you'll get a nice little printout of how long the build took. Now, obviously, Gradle is also printing this information, but we can then use that information to compare it to, for example, how long garbage collection is taking. How do you measure how long a build took with garbage collection? So the problem we're trying to solve here is sometimes certain builds are doing something, you don't know what, but they caught, like you run a build and it just takes like 10 times longer than the last one. And it could be because the garbage collector is just, in this case, if you look at this build, it's like 90% garbage collection. And the thing is, you're not going to look at the build scan, but if you knew that build was 90% garbage collection, then maybe you could kill the Gradle daemon and restart it. And then that way, if you have a memory leak in your project, it'll start anew. Now, obviously, you should fix the memory leak, but who's got time for that, right? No, I mean, we should all really fix them, but yeah. Anyways, okay, so first things first, this is just a Java method. You go to, it's called management factory.get garbage collector mx beans, right? Naming things is hard. I think someone mentioned that in the chat earlier. Garbage collector beans. What are garbage collector beans, right? So this is the documentation on this object from just in Java. It returns a list of garbage collector mx bean objects in the Java virtual machine, and these have information about how much time was spent garbage collecting. Okay, so you basically take those beans. They have a collection time, which is just every bean is a garbage collection event, and you just sum it by the time, and that'll tell you how much time the JVM has spent garbage collecting. The thing is, it starts like it's the entire JVM. So if you're running the Gradle daemon, that'll be for the life of the whole Gradle daemon. So what you need to do is take the start time and the end time and compare it, and that's how much time you spent garbage collecting. So yeah, if you take this code right here, it's basically just running the same thing twice. It'll tell you how much time your build spent garbage collecting, and you can print that out to the console. Awesome. But in this case, we only want to print it if the time is high. So the way you do that is you just compare. This is just taking the code from earlier. You have the start time and the end time, the start garbage collection time, the end garbage collection time, and if you divide them, then you get the percent of time that the build spent garbage collecting. So in that case, the build spent 1% garbage collecting, which is not, no, 0.01% garbage collecting, which is not a big deal. But if you were to see this at the end of your build, then you'd be like, okay, I'm wasting my time garbage collecting. And honestly, who wants to spend their life garbage collecting? Nobody, right? It's a problem for apps. It's a problem for your build. So this is a little message that the Gradle doctor prints out when it detects that your build spends a lot of time garbage collecting. All right, so on to the next event. So the next thing we're going to solve is when your build spends too much time in Dagger annotation processing. So at Soundcloud, we use Dagger Reflect. Dagger Reflect, as well as Dagger for release builds, but developers can opt in to using Dagger Reflect. But how do they know how effective Dagger Reflect is? Well, if we tell them how much time they could save, then they'll know how effective it is. And how do we do that? Okay, so the build scan has, I don't know if you guys have looked in the build scans really deeply, but it'll tell you how much time all your annotation processors spent in that build. So in this case, this build spent a lot of time in the annotation processors. So I asked in the Gradle Slack, would it be possible to print the amount of time spent in annotation processors immediately to the console? And the answer was that the build scan plugin is not open source. Well, if Gradle Enterprise can do it, or the Gradle build scan can do it, so can we. So we ripped open the jar. We take a look at how the Java compiled data store is calling the function A. And we all know that function A calls the event sync with its also function A. And inside A, we get this result.annotation processor details. Here, the method is fully named. And the reason for that is that it refers to an actual Gradle class, like a Gradle class in the public Gradle API. And that method is called compile Java build operation type. Okay, so how does this whole piping mechanism work? Yeah, I know I was just calling a.b.b.c, whatever, but the way it works is we're gonna break apart the Gradle build scan plugin, right? Okay, so Gradle internal extends Gradle. When you're looking at Gradle, it has all the public methods that you traditionally used, and that's on the interface Gradle. But there's also Gradle internal. And when you're looking at the Gradle source code, it's really interesting because it actually tells you what's used by the scan plugin. So you can kind of figure out what parts of Gradle the build scan plugin is using. And what it's using here is get services. And the service registry has, all the Gradle services. And one of the services it has is the build operation listener manager. And this is a really powerful API. So how do we obtain this API, right? We call Gradle internal by just casting Gradle to Gradle. Now, if you're using Groovy, you actually don't need to do any casting because Groovy is magical. But in this case, we're using the KTS, and to make it a little bit more explicit, we're gonna use the KTS. So Gradle internal.services, the services is just a map, and we get the build operation listener manager. And here we can add a listener. And this listener gives us 3 callbacks: progress, finished, and started. Oh, but before I get into that, progress, finished, and started, which gives us all sorts of fun information about your Gradle build. I want to say that there is a danger to poking in internal APIs. And the danger is that this is actually, if you do this in your build, you just created a memory leak. Why is this a memory leak? Well, obviously you read the documentation when you were looking at this class, right? Nope. That is the lesson of this talk, right? Nobody reads warnings. Well, I didn't read the warning either. There's one listener for the life of the build. Listeners must be sure to remove themselves if they only want to listen for a single build. So yeah. What do we need to do? We need to remove our listener. So we just store it as a variable. When the build starts, we add the listener. When the build finishes, we remove the listener. Otherwise, you get a memory leak, and then you get a ton of garbage collection events. Luckily, you get a warning about it. But yeah. So anyways, that fixes the memory leak. Okay. So we have a bunch of callbacks here, but in this case, we're only for now, we're going to just listen to the finish event. And the finish event gives us a build operation descriptor and an operation finish event. The operation finish event in this case has a start time, end time, as well as a result object, and the failure if a failure happened. The result object in this case is what we were looking at earlier, which is the compile Java build operation type, and it'll give us the annotation processor details. You just have to cast it. So let's take a look. So the compile Java build operation type, really great name, is part of the Gradle public API, and that's why in the build scan plugin, even though the build scan plugin is obfuscated, it is still shown. So anyways, you can see it's funny because it says not used by the scan plugin, but it is used by the scan plugin. But anyways, it's an interface. It has a result. It has annotation processor details. Annotation processor details has 2 pieces of information which are really useful: the class name, so we can tell if it's a Dagger annotation processor, and the execution time in milliseconds, so we know how long it took. Okay, so in the callback, we have our build finished callback. We take a look at the result. That's the object. If we can if the result object is a compile Java build operation type.result, then we grab the annotation processor details. If it contains the word Dagger, that means that either it's the Dagger annotation processor or the Dagger Android annotation processor. We just add the amount of time it spent executing to our total Dagger annotation processor time. Pretty straightforward, right? Yeah, once you get the hang of all the Gradle hackery, it's not too bad. And then at the end of your build, you just print out the Dagger time. And that's really it. The only downside to this is this only measures annotation processor because it's the compiled Java build operation type result. So if you're using capped, this will not measure it. And this is because the Java compile task is owned by Gradle, as is the annotation processor, but capped is built by JetBrains. But the build scan plugin is closed source. So how does Gradle tell JetBrains to build an API to report their annotation processing time for a thing that doesn't have a public API? So this is where politics crosses coding. So yeah, we can't measure capped. And unfortunately, we use capped a lot, and it's a little bit slower than the Java compiler. So that's kind of unfortunate. But one thing we can do is we can show the processor timings, and we can print out the amount of time spent in annotation processors to the console. And this is what it looks like if you stick this in your build script. When you start running your code in the logs, if you read through them, you'll see how much time you're spending in Dagger. And of course, the build scans have all the logs. But wait, that means we're really close. This information is in the build scan, right? If it's in the build scan, that means we can get it. How do we get it? All right, so there's progress events, there's finish events, there's start events. If we look at the progress event, there's a very specific progress event that we want, and it's called log event build operation progress details. By the way, before I go into a lot more detail, all these listeners here, the progress, finish, and start event, emit hundreds of different kinds of events and different types of events. So you really have to dig through to find what you want. Like basically every task will emit when it's cached, when it's packed into the build cache, when it's unpacked from the build cache, when, obviously any log events will be put in there, annotation processor events. Like, okay, there's a lot of information. So you really have to dig through to find what you want. But I found log event build operation progress details. And this event has the message, has a throwable, the category, the log level. In this case, if we're looking at this log message, right, and we look at the details, because W, the first thing is the level, second thing is, I can't remember. But anyways, if it's the detail event, we can just use a little regex to parse out the total time. There's a couple of time printouts there because of the number of rounds, whatever, but we just want the total time. And just like before, we add that to the total amount of time spent in Dagger. So yeah, we're using the same variable as Java in case we have a mixed code base and we have Java annotation processors and Kotlin annotation processors. And then we just print out at the end of the build. Cool. So then you get a nice warning if your if your build is spending a bunch of time in annotation processors, and then developers will know, okay, I'm spending a lot of time in annotation processors. I can skip that by using Dagger Reflect. Dagger Reflect, that's a whole nother talk. But if you go to my website, I'll have a link later. It'll show you how to apply Dagger Reflect to your project. But there's so there's another part to this talk, which is we're doing a lot of Gradle hacking. We need to make sure we're not causing problems for our build. So this is where we use Visual VM to attach to our Gradle daemon. And what we can do here, basically, we just want to run the build a bunch of times, attach the Visual VM, and make sure that the number of objects retained by our plugin is not out of control. The first time I did this, you can see here, this generations all the way on the right side. You can see there's 26 generations of this same closure, and then you can tell there's a memory leak. So this is what would happen if you didn't remove the build listener at the end of every build. So once you do that, you get back to, yeah, 1 generation. The other thing is when you're doing a lot of hacking and you're listening to all these objects, you want to make sure that you're not affecting the performance of the build. Oh yeah, I can't tell what slide is next because I don't have 2 monitors. So with that, you can use the Gradle Profiler. I won't get into the details of how to use the Gradle Profiler. You can find that on the Gradle Profiler GitHub page. But you basically just run a build. It'll run 6 warm-up builds. This is to warm up the Gradle daemon because the first time you might have to download dependencies, caching, whatnot, and then it'll take an average of the Gradle builds for this certain scenario you run. And it's really important to do this when you're reading these like hundreds of thousands of events from the build operation listener. So yeah, in this case, I ran the benchmark. It'll give you the mean, standard deviation, confidence interval after running the build a bunch of times. And in this case, it was about 68.5 seconds without the Gradle Doctor and 70.1 seconds on an average of 5. That should say 10 builds with the Gradle Doctor, and the standard deviation was 10 seconds. So I concluded that there's no significant difference in the impact on the Gradle build. All right, so what other cool things can we do with this information from the build scan plugin? I think I have, 9 more minutes. Yeah, all right. I just want to make sure I'm not running out of time. So another thing we can do, and I'm not going to go into detail on this, but you can, since we're all working from home, build scans have information on how fast your connection to the remote build cache is. And so we can warn people on when they have a slow connection to the build cache, because you're not going to be checking every build. Not every build downloads things from the remote build cache. But if you were to just print out, hey, this build had a slow connection to the build cache, when it happens, then you might say, okay, I need to disable the build cache or turn on offline mode. So the Gradle Doctor does that. And this is what that printout looks like. And so is the remote build cache worth it? I actually wrote, you can do this calculation, the cache size, how much size the build added to the build cache divided by the build duration is the minimum connection speed you need to your build cache. I know this equation is super confusing, but anyways, in the Gradle Doctor, you can benchmark how fast of a connection you need to the remote build cache by adding this Gradle flag and just running any task in your project. You'll get a nice report here that tells you how fast your internet connection needs to be. This is done by taking all those progress events. It basically takes the progress events from the build listener API, and it takes the caching events from that same API, merges them together, looks through your build cache to see how big those artifacts are, and then prints out this report. I know what I said is a little bit confusing, but if you go to my Medium, I wrote a blog post on how you can benchmark the build cache, and I think this is kind of really interesting information these days as we're all working from home. It's important to make sure that you're actually getting a benefit from the build cache and it's not slowing down your build. So if you go to my Medium, you can check it out there. But yeah, you can basically do hacking on any information that's in the build scan, turn it into actionable pieces of information using the build operation listener API. And that's what this talk is all about. So yeah, to sum it up, we ensured that our Java home match. We warned when a build takes excessive amounts of time garbage collecting. We warned if our build spends too much time with Dagger. And we warn if we have a slow connection to the build cache. And we can also create a benchmark for the remote build cache. And I know everyone likes warnings in their Gradle builds, and this only adds more warnings, but that's life, right? Anyways, I'd like to thank everyone for listening to this talk. I really hope you enjoyed it. Also, I know we're not in person, so things are a little bit different, but feel free to get in contact with me, to send me an email, to go to my website, to tweet at me. But I will also open the floor for questions right now. Let me just figure out how to do that. I know how to do this. Yes. Okay. All right. Okay. So I'm looking at, someone also added me. There's a Slack channel apparently about my talk. Okay. So you mentioned how to monitor garbage collecting time, but when time is high, how can you optimize garbage collecting on build time in order to optimize it? This is a really good question. So in the warning message, it says two things, and I kind of glossed over it. So it's good that you're asking me this. There's two things that garbage collecting time could be a sign of. The first is that your Gradle daemon heap size is too small. So, it could be as you get a bigger code base with more Android resources that you're processing, more modules, more code, you just need more heap size to process the additional amounts of code. And in that case, you need to increase your heap size. The second thing that high garbage collection time can indicate is that there's a memory leak in your build. And so how do you tell when it's either case? And this is also in the warning message, but if you're getting high garbage collection times after your first build, that means that your Gradle daemon is too small. If you're getting high garbage collecting times after running like 10 builds, 12 builds, whatever, then that means you probably have a memory leak. Cool. All right, that answers the first question. I hope I answered that well. The next one, your Gradle code tips are great, but can be time consuming on a day-to-day basis. Do you have some tips or resources for build time analyzing from a build scan user point of view? Hang on, I'm not sure if this refers to, let's see, looking at, is this like just taking a look at random build scans or? Because, okay, so I guess the talk is you can apply the Gradle Doctor plugin, and then that'll give you all these tips and it'll print out that information and it'll tell you like how to fix certain of those issues. Using the build scans from a user, it's really just like kind of digging around and just finding problems. You'll kind of get a feel for it. Like the other day, I'll give you an example. I was running a test in a small module and I noticed that it was taking a long time. So I looked at the build scan. I noticed it was like recompiling most of our app, even though this module didn't depend on the whole app. So I was like, okay. And then in the build scans, you can see task dependencies. And I realized that the task dependencies, it depended on, the whole app in the test sources. And then I dug in why that was, blah, blah. But yeah, certain tasks will cause rebuilds that you think shouldn't happen. So that's I guess, I hope I answered that question. Feel free to ask another question if I didn't answer that well. Okay. How did you find out about cap.show processor timings? It's a good question. I did this a long time ago. I'm not sure if it was a question I asked in the Kotlin Slack. You can also just look at because KTS is typed, if you look at the capped extension, you can see all the options that are available as part of the capped extension. And there's a lot more options too. Like for example, this is also, the capped extension is also where you can like turn on and off capped build caching. So you can, yeah, you can, if you have build.gradle.kts, you can just look at the capt extension. Otherwise, you can look at the sources in Kotlin itself. Thank you. Isn't relying on internal Gradle implementation something risky? Is it something stable under the hood? Yeah, there's absolutely no guarantee that any of this will be stable. So what I do in the Gradle plugin, in the Gradle Doctor, is I run the tests against the oldest supported version of the plugin of Gradle, which is 5.4, and then I also run it against like 6.0, 6.2, and the latest version, and it'll give me certain confidence that it'll at least continue to work on those versions. But yeah, there's no guarantees that these will continue to work in the future or anything like that. How to spot the causes of leak in the build? This is a really good question, and it's really hard. So yeah, you can use the Gradle VM to like examine. So for example, if you're adding a plugin like my Doctor plugin, I can search for the number of instances of this plugin, right? It should always just be 1 or 0. That's one way of looking for memory leaks. The other one is you can take the heap dump and then load it up in something like, what do you call it? Eclipse Memory Analyzer tool or any other heap dump analyzer. And then you just gotta dig, right? And it takes a little bit of feel because, you kind of can tell what an Android application is supposed to look like you only have one activity. But when you're looking at a Gradle heap, it's a little bit different. And I don't really have a good answer for this, but you're kind of like, okay, should there only be one of this object? Should there be more than one? Yeah. And then the last question, am I fed up with Gradle? Yes. Gradle is it's quite the tool. Yeah. But that's a really good question, actually. I guess I'll take this opportunity to announce it. I'm actually leaving my position at Soundcloud at the end of this month, and I will be starting to work at Gradle. So thank you for asking that question. I'll be fed up at Gradle, but it'll be my job from now on. Okay, so thank you everybody for the all the feedback, all the talk, and the questions and everything, and it's been really fun. So thank you.